We'll see. Find the derivative of x squared plus 3x. So your derivative formula is our limit as h approaches 0 of, why don't you go ahead and do this one on your own, and then choose who's going to give us their answer. Raise your hand if you're done. Okay, it'll be another minute. Counter until you. Squared out x plus h. Is x squared plus 2xh plus h squared, because you've got your outer and your inner. Okay, so that's going to apply. Now raise your hand if you're done. Haley, what'd you get? Did anybody get anything else other than 2x plus 3? Raise your hand if you got 2x plus 3. Raise your hand if you did not get 2x plus 3 and you are willing to offer up your paper for the good of the group so that we can learn from your mistake. Raise your hand if you did not get 2x plus 3. Okay, Josh, what's your question? No. So this is giving us the general formula. So this function, gosh, this is x. Hold on one second. I just want to sketch a somewhat accurate picture of this. This has a 0 at 0 and negative 3, and it's a parabola that opens up. There's a general sketch of our function. The derivative formula gives us a way to find the slope at any given point. So you couldn't be asked to write an equation of a tangent line until you know what point you're writing the equation of a tangent line at. Okay, so if they give you a point like at 2, they want you to write the equation of a tangent line at 2. Is that what you're saying? Right, so but they gave you a point at which they wanted you to write the equation of the tangent line. So at the point 2, I need to know, first of all, the point, 2 comma what, and I would get that from here. 2 squared is 4, plus 3 times 2 is 6, 4 plus 6 is 10. So the point is 210. And the slope that I'm going to use to write the equation of this line is going to be given by f prime at 2. That'll give me the slope at 2. So you would plug 2 into here, and 4 plus 3 is 7. So then you'd be writing an equation with a point and a slope there. So you don't really write the equation with that equation. Anything else? Okay. So the second part is to just use that derivative to find the slope of the function at -2. So that's just f prime of -2, which is 2 times -2 plus 3. -4 plus 3 is -1. And you can confirm, look at -2. So this is half, the vertex is at -1.5. So -2 is probably right around there. We can confirm that the function is decreasing there. So a negative slope makes sense. And then -3/2 is the same as -1.5, which is actually the vertex. So we should expect the slope to be what at the vertex? 0. And sure enough, if you plug that in, your 2's are going to cancel, so it's just going to be -3 plus 3, which is 0. Okay, the next one's just going to be a little bit grosser. So yes, we're still doing the same thing as yesterday, but we didn't have a cubic function yesterday, right? So let me just quickly sketch a cubic function, because we can, and it helps to kind of round out our understanding. X cubed minus 2. So this is just our parent graph shifted down 2 units. So it's going to look something like that. So we're going to find the derivative. Now, first of all, what can we say about the slope of this function no matter where we are? The slope is always increasing, so it should always be a positive slope. So when we find our derivative formula, we'll take a closer look at why is that derivative formula only going to yield positive results. Because obviously that has to be the case if this graph is always increasing. So go ahead, take a minute, and find your derivative. Do it on your own, and then we'll come together and check. Raise your hand if you're done. Raise your hand if you feel stuck. Raise your hand if you found a mistake and now you're going back and fixing it.
There wouldn't be a big difference. Because you limit as h goes to 0 all the time. You keep that limit as h goes to 0 all the time each step. And then when you plug in an h of 0, then you have to make all of that. 3x times 0 is gone. So then you're just left with that first piece.
Randomly collect 3 papers. Raise your hand if you're done. Okay, let's start with this one. I don't know whose this is, so we'll all play teacher together. Okay. So take a minute to review and play teacher and decide if this is correct or if you found a place where we got sidetracked. Why don't you pick a number between 1 and 25? Taylor? Which step? Step 1, 2, 3? Here, this is step 1. This is step 2. So between what and what? Between here and here. They didn't distribute right. Correct. So if they distributed their x, it's the cubing, right? These can get not difficult, but overly tedious and ugly, right? When you're cubing a binomial, it's not difficult. It just takes being super, super careful, especially when you've got 2 variables involved. So she distributes the x cubed, 2hx squared, and h squared x. And then it's this one right here. H times x squared should be h with an x squared, not x with an h squared. So that's going to now affect what got combined, right? That got combined with the xh squareds when it should have been combined with the x squared h. Okay? So that was correct, Taylor. Good, good, good. And let's take a peek at this person's. I'm just going to look to the bottom. And this is correct. So whoever this is correct. They've got their limit carried all the way down. The work is beautiful. Only a math teacher could say that about appreciating how clean this is. And then they actually are about to apply the limit, so they plug in their 0, and so they don't need that any longer, and the derivative is 3x squared. So f prime of x equals 3x squared. Adam. You have what? There is a binomial expansion formula. You might be. We don't use that. Why would you? What would the logic be behind? You're just kind of. There's the. Oh, maybe you're combining those thoughts. Did you do binomial expansion? Like the rule behind taking x minus y to the 5th power? Did you ever do that? There's like shortcuts. No, it's been taken out of the curriculum. So where did you do that, I wonder? Because it is a thing. Yeah. This is the trouble with formulas. This is why I try not to memorize formulas if they're not necessary. Because then they just all get intertwined, and then you just go based on what you memorized 6 months ago, which you haven't used in a while, and so it's stale, and then you get the wrong answer. Versus if you just go back to the conceptual piece, which is multiplying something by itself 3 times, you multiply the first 2, and that we do enough where I don't think the shortcut gets stale, because it happens all the time, squaring a binomial. And then when you multiply by that 3rd binomial, you just really go through it conceptually in quote-unquote the long way, but you're accurate because the formula you might memorize wrong, which we've never even taught you the formula for cubing, I don't believe. I don't even know it. I would have to, I could create it, I could come up with it just by practicing, but if you're going to do 75 problems in a row, yes. Because that's when you want to use your shortcuts. That's when you want to use your formulas, is if you've got a boatload of these things that you're doing all, at the same time, and it's going to quicken and automate that process, right? But if you're not, then, and you're going to use it sparingly once every 3 months, you're going to misremember the formula. So that's, kind of the situation where I wouldn't want you to do that formula. It's like, you're making me think of the conversion between Celsius and Fahrenheit in an example I used to use, where whatever that, it's Celsius equals and then the Fahrenheit side. And if you're, well, without showing you this is just going to go over your head, so I'm not going to say it. But anyway, I'm not a big formula person unless it's something that you are going to use often. Or if it's something that conceptually, sometimes there's those formulas that, thank goodness there was a genius somewhere who came up with this shortcut, because conceptually we aren't at a spot to understand it, so we just take the formula and trust in it. In those situations, yes, understand the formula, because conceptually we're not at a place where we can understand it. So that's the best we can do. But if you're at a place where you can understand it, I don't see how a formula is helpful. Unless you're doing 75 of the same problem in a row, then it's helpful. So anyway, this is correct. So we have nothing to really review on there. This person just didn't quite finish the two questions at the bottom. F prime of -1. So the slope at -1 is what? 3. And the slope at +1 is 3. And actually, now that we have this in front of us, compare it next to the graph that I had on the side here. Do you see why our derivative formula, our slope formula, is always going to be positive? Right? No matter what value you plug in, you're squaring it. And then you're multiplying it by a positive number. So it's always going to be a positive slope. Good? And this last one was also done correctly, so we don't really need to. That was good. All right, so Nathan, handles to Nathan, please. We'll go back to him first. He can find his and pass them along to Zach and Ron. Good job. Okay, on the back, another derivative problem with decimals. Maybe a calculator question. Let's see how far we can get without one. There's my f of x plus h minus so I just squared out my binomial on that first term, distributed my negative 1.4 on the second chunk, and then distributed my negative on the minus f of x. And then on my third step, I'm going to actually distribute that 1.3. I got to tell you one of my pet peeves. You can raise your hand and tell me if you did it. How many of you squared out the x plus h and distributed your 1.3 all in one step? Ugh! I know you can do it. It sort of drives me nuts.
It's a giant.
I know. It's not wrong. It wouldn't take off, but sometimes I find it very hard to follow when I'm trying to read. If you make a mistake and I'm trying to go back and figure out where you made your mistake, it's just much harder for me to diagnose your mistake, and your partial credit suffers if I can't figure out where you went wrong. Just letting you know. But if you do it accurately, I'm not going to complain. Just be careful when you try to combine two steps. Okay. So we didn't need a calculator. That was a scare tactic. Throw a decimal at you. And then we're finding the slope at 0. And we're finding the slope at 4. Uh-oh. Getting nervous. 26 times 4. 104. What's that? 10.04. That's 104, so 10.4. Yes? See what I did there? Mental math. 26 times 4. Well, I did 26 times 2 and got 52. And then I doubled that to get 104. But 104 is obviously not the answer. I got to move that decimal place back one. 10.4. Anyone do mental math there a different way? What'd you do, Liam? 80. Or 8. Another 2.4. So you kind of did 4 times 6 and got 24 and moved your decimal. So you did 80 plus, or 8 plus 2.4, which is 10.4. Good. Any other methods of mental math worth sharing? Because I know this is something that we're working on. Adam? Four, so you did 4 times 25 and got 100. And then 4 times the 1 extra from 25 to 26 that you left out is an extra 4, so that's the 104. And then you backed up. So you did the 4 times 26 differently than I did the 4 times 26. But you still thought about 26 and not 2.6 and worried about your decimal later. Good. Anybody else? No. Okay, good. So any of those strategies, all good. So 10 point, what do I say? 4. Okie doke. Oh, sugar. See, I got so caught up talking about mental math, I couldn't even finish it out. Not a closer. Not a closer. All right. Last one here with a radical. So go ahead on your own, find the derivative. Couple rough patches we might come across in here. Little algebraic mistakes to be very, very careful with. Should I collect 3 randomly again? Raise your hand if you're done. Okay. Here goes nothing. I'm going to start with the 1. This one? All right. I'm looking for some quality, teacherly feedback. So take a minute. Nope. No, this is teacher ding, so I'll go to my next in line. And we'll fire through until we get a good teacherly answer. Maria? So here. Correct. So, Adam, the binomial is this minus this. So the conjugate would be this plus this. Okay. So that's good advice. And you're correcting one of his runs. And there's confusion here because there's an outward-most binomial, and then each of those terms is a binomial, right? And then inside that, there's another binomial. So that's kind of the binomial within a binomial that's causing that confusion. But something else to simplify his life. Connor? Jalen? So you're talking here? Well, we can't really discuss that part because this was incorrect. That's what Maria said. That's what Maria said, but this is wrong. But prior to that, I'm looking for good teacherly advice. Nathan? Stephanie? Right, and that's going to cancel that for you, right? So before jumping to the conjugate, how about we simplify the numerator? So this plus 2 and then the minus 2 will cancel. So then your numerator is really just the square root of x plus h minus 1 minus the square root of x minus 1 all over h. So now your conjugate can be this plus that, and the 2's are a non-issue. Then you're not foiling within foiling because of those binomials within binomials. Do you see that, Adam? All right. So, and then you would take that from there. Let's check. You know that's a hidden talent of mine. I can talk with my mouth closed.
What I'm not talking about this afternoon.
Did you hear what I said? Yeah. It's a hidden talent, isn't it? I don't know when I developed this, kids, but it is noteworthy. Okay? All right. I apologize for my puffed cheeks when I have to do it. So I really can't read this one. Does anybody... Who's giving me capital H's? That's why, well, first of all, that's part of the issue. We're using capital H's. So here's the f of x plus h minus f of x. This person doesn't even have the whole difference quotient. Here's the f of x plus h. Then it should be minus f of x, which I don't see, all over h. So they missed that part. and immediately jumped to the conjugate. So I'm going to bypass. Oh boy, here's someone that thinks they got the job done. So all of this. All right, teacher game. So this, welcome to my world, see? This is what I have to sit. This is why we go all multiple choice on your tests and quizzes, because this would take me, this is just one of 65 papers I'd have to look at. Now you see. Now, not to mention the different variations, because it's not that this method can't work. This person did not take on Stephanie's advice, which was to distribute that negative first so that the 2's cancel, so that you can multiply a conjugate without having binomials within the binomials. So it's not that this can't work, it's just ugly, right? So they multiplied by the proper conjugate, this plus this. They're foiling. So this is what I'm talking about. When they start foiling, this times this is foiling within the foiling, right? Don't go down that path. It's ugly, but it's not that ugly. Okay, so when you multiply this times this, that would be foiling within the foiling, which would be x plus h minus 1 plus 4 of these radicals, which they missed. Right, it's 2 radical plus 2 radicals. That would be 4 of the radicals plus 4, so we just went astray there. So here's what should have happened. So there's my f of x plus h minus my f of x all over h. I noticed my 2's could cancel, so then it cleaned up to this. Now I go conjugates. Sit down, Josh, you're making me nervous. Now I go conjugates, foil out, everything cancels until we have just an h in the numerator, which reduces with the h in the denominator, and then I can plug in my 0 for h and get my derivative. So the derivative is 1 over 2 root x minus 1, and then I evaluate at 2. What's your problem?